Guys, you are back again on my YouTube channel. As you can see on the board, today we are taking the third phase of our Jamb mock chemistry question. So look at the board, you will see Jamb mock chemistry question part 3. But what we are going to do first is that we are going to solve the assignment problem that was given in our previous video. And in this assignment problem, we have it as question number 14, question number 15. We are going to take these two problems first and solve it before we take other questions that we have for today. Please, if today is your first time for coming across this YouTube channel, we have a lot to offer you in your forthcoming Jamb and XSC examination. Or if you are writing other exams that are related to higher institution, this channel is the best channel that you can link up to. Okay, so we are going to start with question number 14 before we take our question number 15. Question number 14 says, what is the temperature of a gas initially at 17 degrees Celsius and 12 atm if the pressure is increased to 36 atm? Atm simply means your atmospheric what? Pressure. Now, if you look at this question very well, you will have to first of all look for the law that is based on temperature and pressure only. Now, this is one of the 9 laws of gases. One of the 9 laws of gases, which is basically called pressure law or the Hamilton's law. And according to pressure law, it says that the pressure applied by a gas is directly proportional to the temperature of the gas as long as your volume remains constant. So pressure laws have it that our pressure is directly proportional to the absolute temperature in Kelvin, and that will give us pressure equals to K times your T. By the time you divide both sides by T so that you make your K subject formula, you will have that K is equals to P over T. This is your pressure law, where your K is known as the what? As the constant. So what we are having here is that we have P1 over T1 is equals to P2 over T2. This is your initial pressure, this is your initial temperature, this is your final pressure, and this is your final temperature. Like I told you, what is this law that they are referring to? They are referring to pressure law. Please take note of this. It is pressure law. Pressure law has to do with pressure and temperature together while your volume remains constant. If it was Boyle's law, it should have been volume and pressure and so on and so forth. So let us first of all bring out our parameters from the question given, and then we are going to apply this formula in solving the problem. What is the temperature of a gas initially at this? This is the initial temperature. So our T1 is equals to 17 degrees Celsius. Don't forget, you must convert your degrees Celsius to Kelvin by adding your 273. Okay, if you add 17 to 273, you are likely to get 290 what? Kelvin. Okay, now the pressure P1 is equals to 12 atm, which is atmospheric pressure. Now, if the pressure is increased to 36, okay, so we have it that our P2 is 36 atm. So what will be our T2? What will be the final temperature of the gas? That's the question. So let's quickly take our T1, our P1, and our P2 into this formula so we can get our T2. So P1 is giving us 12 all over T1. Our T1 is 290 equals to P2. Our P2 is 36, while our T2 is unknown. Okay, so what do we simply do? We'll cross multiply so that this will multiply this to give us 12 T2 equals to 290 times 36. And then we can divide both sides by 12 divide here by 12. So this cancel this. T2 will give us, if 12 go into 36, we are going to get 290 times 3. Let's multiply 290 by 3 to see our answer. Wow, our answer is 870 Kelvin. 870 Kelvin. So if you look at the option, you'll see that the option is not A, but the option is B. Now, that's great. Let's quickly take question number 15. Question number 15 is strictly from Organic Chemistry 2. Organic Chemistry 2. It is from Organic Chemistry 2 and it's based on polymerization reaction. Remember, I told you in my previous video that polymerization is a process by which two or more simpler molecules called monomer combines together to form a giant molecule which we call the polymer. That is to say, in polymerization reaction, we have monomer. The word mono means one, plus another monomer, plus many other monomer will give us what? Our polymer. So these two guys are known as what? Simpler molecule, while this one is known as the what? Giant molecule. So polymerization is the process by which two or more simpler molecules, which we call the monomers, combines together to form a giant molecule, which we call the what? Polymer. That is what we call polymerization. I told you before in my previous lesson that polymerization is of two types. We have what we call the additional polymerization and we have what we call the condensational polymerization. In additional polymerization, it involves similar monomers. For instance, if I combine 18 plus 18 plus 18 plus many monomers of 18, it's going to give us polythene. Polythene is the polymer of the monomer called 18. If I have something like ethyne plus ethyne plus ethyne, it's going to give us a polymer which we call C6H6, called what? Called benzene. So as far as polymerization is concerned, the polymerization of ethyne will give us what? Benzene. So these are monomers, while this one is called a what? A polymer. You can combine ethene to give you polythene. You can combine ethyne to give you polythene. You can also combine ethyne to give you what? Your benzene. So this is what we call additional polymerization. In additional polymerization, there is no elimination of any molecule like water or ammonia. But in condensational polymerization, it involves the elimination of either water or what? Ammonia. For instance, can you give me a simple example of condensation polymerization? Yes, I can tell you that if we have glucose, which is C6H12O6, plus another glucose, C6H12O6, these guys are called monomers. If you combine two glucose together, it's going to give you a what? A disaccharide called C12H22O11 plus H2O. As you can see on the board, this guy is a monomer. This guy is a monomer. But this guy is a polymer. So polymerization is when two or more monomers combine to give us a giant molecule called the polymer. Okay, it could involve the elimination of water as it is in condensation polymerization, or without the elimination of water as it is in addition polymerization. So that is the two types of polymerization that we have. As you can see, this one is called condensation polymerization because it involves the elimination of water. If water is eliminated, it's condensation. If ammonia is eliminated, it's condensation. So let's quickly go to this number 15. and see the answer to this question. Okay, the question says diamine. Diamine, it means an amine that has two of the functional group, and dicarboxylic acid, meaning that the carboxylic acid has two of their functional group. By the time diamine polymerize with dicarbonxylic acid, what are we likely to get? When you combine hexane 1,6-diamine, which is talking about this, hexane 1,6-diamine and hexane 1,6-dioic acid, because as you can see, di means two. So what we actually have is hexane 1,6-diamine. That's what we have for diamine, and we have hexane 1,6-dioic acid, which is our carboxylic acid. By the time this monomer combines with this monomer, what will be formed will be called a polyamide. Please take note of this. It is called a polyamide, which is basically called a nylon. Wow, that's interesting. So let's quickly look at the option and see the answer to this question. Please be careful of option A. It said polyamine, which is not the answer. Option C says polyesters. No, not the answer. Option D says polythene. Not the answer. The answer is polyamide. So take note, the polymerization of diamine and dicarboxylic acid gives us polyamide. Okay, let's quickly go over to the questions that we have for today. Please take note of these important answers. Question number 16. Which substance is added to table salt to prevent goiter? Which substance is added to table salt to prevent goiter? Wow, very cheap. The answer to this question is what? Iodine. Don't forget that. Iodine is usually used to prevent goiter. Goiter simply means lack of iodine in our diet, like this, what causes the swelling of the thyroid gland because of the lack of iodine in our diet. So if you want to prevent goiter, you have to add iodine to the salt. Thank you. Question number 17. The number of hydrogen ions present in 9.8 grams of H2SO4 solution is what? Wow. Now let's solve this question. Now remember, if H2SO4 ionizes, is going to give us 2 moles of hydrogen ion plus tetraoxosulfate 6 ion. This is what it will give us. This is the ionization of a dibasic acid. Now, if you watch very well, the question says that the number of hydrogen ions. So we are looking for number of hydrogen ion here. We are looking for ions here. Okay? The number of hydrogen ions present in 9.8 grams. They gave us the mass of the acid, but we are looking for the number of ions of hydrogen. So here they gave us the mass, but here we are looking for the what? The ions. So this is likely to be called mass to ion what? Relationship. You have to first of all establish that fact that here what is required is the mass, but here what is required is the ions. Okay, now what we simply do is this. Let us first of all, since we need mass here, let's calculate for the molar mass of H2SO4. How do we get the molar mass of H2SO4? Let's do that quickly. Remember, H2SO4, you take the masses of each of the atom in the molecule. Hydrogen is 1, so you have 1 times 2 plus your 32 plus 16 times 4. And that will give us 2 plus 32 plus 64, and that will give us 98 grams. So the mass, the molar mass of H2SO4 is 98 grams. If we have 98 grams, remember, it is mass to ions relationship. First of all, let's do this quickly. 98 grams of H2SO4 has given us 2 moles of hydrogen ion. 98 grams to 2 moles of hydrogen ion. The question now says that what will be the number of ions? See, before you can calculate for the number of ions or number of molecules or number of atoms, you need to know the number of moles, because the number of ions is number of moles times your Avogadro's constant. So we need to know the number of moles first, but have it in your mind that we are looking for the number of hydrogen ions. So now the question says that 9.8 gram will give us what? 9.8 gram will give us X mole. We are going to get X mole. So what we quickly do is to cross multiply this with X times this will give us 98X equals to 9.8 times 2. So when you divide both sides by 98, divide here by 98, this cancel this, X will give us, if you divide this, you have 0.1 times 2, and that will give us 0.2 moles. Let's quickly check if we are correct. Yeah, we have 0.2 moles. So this is the number of moles, not the number of ions. Remember, number of atoms or number of ions or number of molecules is equals to the number of moles times your Avogadro's constant. Your N is your Avogadro's. I made a video last time on mole concept and calculation involving mole concept. So you can go back to that video to see how you calculate for number of atoms or number of molecules or number of particles or number of ions. So for this particular question, the number of ions is the number of moles that we have gotten times our Avogadro's constant. So that will give us 0.2 mole, which is the number of moles of the ion, times 6.02 times 10 raised to power 23. So let's quickly see what our answer will be. 0.2 times 6.02. Remember in UTME exam, the calculator that will be given cannot get this exponential value. So what you quickly do is to multiply 0.2 times 6.02. You have 1.204. You have number of ions or number of atoms. You have Na here because it doesn't signify number of atoms or number of ions or molecules. Is equals to 1.204 times 10 raised to power 23 ions. That's the answer to the question. So let's check our options. Our answer is not D. Our answer is not this 21. Don't forget we have 23 here, so it's not this. Our answer is B. 1.204 times 10 raised to power 23. So if you are looking for number of ions, it's number of moles times your Avogadro's constant. Question number 18. Pure solvent is obtained by, very easy. Remember that all of these, from what I'm seeing, are processes for matter. Your evaporation means that the substance is changing from liquid state to gaseous state, and that's not how pure solvent is obtained. Condensation is the reverse of your evaporation, where the gas is condensed back to liquid. So that's not the answer. This is not the answer. Extraction is more or less like a general term, so be careful of this option. It's not the answer. Distillation is a method employed to separate two or more miscible liquid of different body point, and distillation is a more reliable technique when it comes to the extraction of a pure solvent. So let's quickly do that. Our answer is what? D. Okay, we have more questions for these lessons today. Let's take more questions for this lesson. Which of these ores is aluminium extracted from? This is the 19th question of your Jamb mock chemistry question 2024. Which of these ores is aluminium extracted from? Now, what are the ores, or what is the ore of aluminium? Now, we all know that aluminium is gotten from bauxite. Please take note of that. Aluminium is gotten from bauxite, okay, through an electrolytic process called electrolytic reduction. The steps is quite very easy. When the bauxite is obtained, it is usually washed using concentrated sodium hydroxide called caustic soda. That is to say, if we want to extract aluminium, what we first of all do is to get our bauxite. By the time your bauxite is washed with concentrated sodium hydroxide. Please take note of it. You can get your book and your pen to note that concentrated sodium hydroxide is used for purifying bauxite. By the time these two combines together, it forms what we call alumina. Okay, now this alumina is the end product of the reaction between your bauxite and your concentrated sodium hydroxide. Now, by the time you have gotten your alumina, alumina is then dissolved in cryolite. Alumina is then dissolved in cryolite. Now, the purpose of dissolving alumina in cryolite is to enable the alumina to conduct electrolysis, to conduct electricity in the electrolytic process, so that at the end of the day, your aluminium will be deposited at the cathode. So take note of the step. First of all, is the purification of bauxite with concentrated sodium hydroxide to give you alumina. Alumina is then dissolved in cryolite so that as to dissolve this alumina and to enable the alumina become a good electrolyte for the process. So by the time the current passes through this alumina, the aluminium will be what? Deposited. Please take note of that. So where do we get aluminium from? Aluminium is extracted from bauxite. If we want to look at other options like limestone, what is the chemical formula for limestone? Limestone is CaCO3. It's also called marble or chips. You can extract calcium from here. Okay, what about your rock salt? Your rock salt is simply your potassium chloride or your sodium chloride. You can call it the rock salt. Then what is your dolomite? Your dolomite is magnesium carbonate that also contains a small deposit of calcium carbonate. Okay, magnesium can be extracted from here too. Okay, so please take note of this, that the ore by which alumina is extracted from is your bauxite. It's not rock salt, it is not dolomite, it is not limestone. Now, question number 20. A mixture of iodine and sulfur crystals can be separated by treatment with what? How can iodine be separated from sulfur crystal? I know you'll be quick to say that iodine is a sublimable solid. So, in that reason, you should use sublimation. Yeah, sublimation would have been the most effective way of separating iodine from sulfur crystal because sulfur does not sublime. Okay, sulfur is a yellow solid that does not even dissolve in water. It does not sublime. But iodine, same for iodine, but iodine is a sublimable solid. So sublimation would have been the best method. But if you look at the option, you will not see sublimation here. So what are the necessary steps that is to be taken when separating sulfur from iodine? Will it be quick for us to note this? Please note this down. What is the solvent for sulfur? Number one, the only inorganic substance that can dissolve sulfur is carbon 4 sulfide or carbon disulfide. That's the only inorganic substance for sulfur. Wow, that's interesting. Now, but we have other solvents that can dissolve sulfur, but they are organic. A solvent like benzene and methylbenzene, also called toluene, methylbenzene. So all of these solvents can dissolve sulfur. Carbon disulfide, benzene, and methylbenzene, they are the solvents for sulfur. Wow, so interesting. Now, if you put sulfur in these guys, will it dissolve? Yes, it will dissolve. Let's talk about iodine. Is iodine soluble in water? No. Can iodine, what is the solvent for iodine? It is simply what? Ethanol. Ethanol is the solvent for iodine. When iodine dissolves in ethanol, it forms what we call tincture of iodine that can be used to clean wool. Okay, that's so interesting. So is either we dissolve the sulfur in carbon disulfide and filter off the iodine, or we dissolve iodine in ethanol and filter off the sulfur. So let's look at the option. A mixture of iodine and sulfur crystal can be separated by treatment with that water to filter out sulfur. That's wrong, because iodine is not soluble in water. Methanol to filter off iodine. That's wrong. Ethanoic acid to filter off sulfur. That's wrong. Carbon 4 sulfide, wow, to filter off iodine. Carbon 4 sulfide will dissolve the sulfur. Yes, it will dissolve the sulfur. By the time it dissolves the sulfur, what will be left will be what? Will be iodine. For instance, take a look at this. If I have sulfur here plus iodine crystal and I add carbon 4 sulfide, what it will do? It will dissolve this guy. By the time this guy is dissolved, it will not be in a liquid world, in a liquid solution. Okay, so the crystals that will not be left will be that of iodine. So you can put into a funnel containing a filter paper, so that by the time the liquid gets to this place, by the time the substance gets to this place, what will be here will be your what? Iodine. Your iodine will be here. Sorry, yes, your iodine will be here, while the sulfur will pass through to become the what? The filtrate. The filtrate will be the sulfur, while the residue will be the what? Iodine, because sulfur is soluble in carbon 4 sulfide, while iodine is not. So the answer to this interesting question is what? D. Now let's get to question number 21. The compound commonly used to demonstrate fountain experiment is what? Remember that fountain experiment requires soluble gases, and the two most soluble gases that are used to demonstrate fountain experiment is simply ammonia, NH3, and hydrogen chloride. Remember, this is an alkaline gas. So if it is used to demonstrate fountain experiment, it means that if I put a red litmus paper, it will turn it to blue. Then remember, this one is an acid, or you can call it a marine acid gas. If this is hydrogen chloride gas, it means that by the time the gas is dissolved in water, it forms hydrochloric acid, and hydrochloric acid will turn blue litmus paper to red because it's an acid in the fountain. Then while your ammonia, because an alkaline, will turn red litmus paper to what? To blue. Now, before we come to the end of this video lesson, I'm going to give you two interesting questions to answer for me. Also answer for yourself, because these questions are certain questions that will come out in your Jamb exam. Okay, I'm going to drop the two questions. Please do well to send your answers to me on the comment section of this video. This is question number 22. The mass of a divalent metal Y that will react with excess HCl to liberate 224 cm cube of hydrogen gas at STP is what? This is the gas molar volume, while this is your what? Your molar mass or relative atomic mass of the gas. And this is question number 23. I'm going to leave this question for you. Please do well to send me your answers on the comment section, not on WhatsApp. Send your answers to the comment section. Now, I have two very interesting materials for you. If you are preparing for Jamb exam, now that your Jamb is very close, and you're looking for a perfect revision guide, this chemistry masterpiece is a short guide for you. It is called Exploit in Chemistry. It is a summary from the first chapter of chemistry to the last chapter of chemistry. With this book, you can cover your full syllabus in 3 weeks, okay? If you want to get a copy of the chemistry masterpiece called Exploit in Chemistry, and this is your physics called Last Chance in Physics, it is also a summary containing all the topics in physics, chapters by chapter summarized. All your formula and your detailed explanations are coded here in this book, okay? If you want to get a copy of this book, you can call or WhatsApp me with the number on the board, or you click on our page in our YouTube channel to get our contact. Thank you very much. I repeat again, if today is your first time for coming across the H2O channel, please do well to subscribe to this channel, and also help us to like and share our videos. Thank you very much. I'll see you in my next video.